Hello, Keith Rucker here at VintageMachinery.org. Guys, today got a little project I'm doing again for a viewer. This is for Stephen Cox, and he reached out to me and asked if I could help him. He is working on restoring, I think it's he said this is a shaft that is out of a hydraulic steering pump out of a 1970s vintage dresser rand roller compactor, and I think he's working on fixing this thing up and needed a new shaft made. This one here has got some pretty significant issues. Looks like this, there's an area here where there's a little roller bearing that goes up on it. It is just, it's just flopping around. So interesting shaft. Looks like we got some bearing surfaces. I'm not exactly sure what all went in this thing. I'm guessing there's a gear that goes on the end here, just based on what's here. I'm guessing that there's a bearing maybe that goes on it here. Got this bearing here. I really don't know exactly. Threaded on the end and splined on the other end that fits up onto this little piece here. And I'm not exactly sure how all this works, but I know what we got to do. We have to build this new shaft. So let me zoom you in here. I'll show you what we got, and we're going to get started on this project. See if we can get this knocked out for Stephen. That's the shaft right here that we got to make, and you can kind of see this is splined on this end. It fits up on this. I asked him to send this so that we could test fit it. This is that little bearing here, but this is really sloppy. That should be a 1/2 inch, and it's just worn down. Like I said, I'm not exactly sure what all goes on the rest of this. I'm assuming there's a key on this. I'm assuming there's a gear or something, a pulley or something on that end that drives this. There's this threaded on the end. What is that? 1/2 inch 20 threads. I've got a sketch here that I made with the dimensions and the links that we can get started on this thing. So I've got a piece of stock. This is just some 4140 I had laying around. It's a little bit bigger diameter than what it needs to be, but that's what I had available, so that's what we're going to use. And we're going to head over to the lathe and see if we can get started on knocking this part out. Well, guys, I think what we're going to do is try to use the 10EE lathe on this job. This is the perfect size job for this machine, and if you've watched the channel regularly, you know this is a machine I just recently restored and put back in the shop into use. I've used it on a couple of just real small quick jobs, nothing that's been on the video. I really haven't used it from like start to finish on a job yet. So this is really going to be kind of a test for me on this machine. And honestly, I'm going to be learning this machine as I go. Anytime you go to a new machine, there's always little tricks and just little, things you need to learn about it. So we're going to be doing that as we do this job. So I've got my piece of stock cut here. I think what I'm going to do is do this job between centers. So I'll put centers on each end. We'll put them between the centers and turn them with a dog. That way I can flip the part around, turn each side, things stay concentric. Don't have to worry about dialing it in on a four-jaw chuck or anything like that. So I think that's just the way we're going to do it. So let's get in here and start by facing the ends and getting some centers put in. Over here and face off the front of this. Put our center in. And we'll flip the part around, do the same thing on the other end. I've got a center in here that I'm going to true up, make sure it's running perfectly true on this lathe. Ideally, I would have a dead center that would fit up into the actual machine, but I don't have one. There we go. Just a little bit more cut It's just truing this up just to make sure it's running perfectly true on the machine, and that's good enough right there to engage what we got to engage. All right, let me get that out of the way, and I'll put a live center in the other end. We'll get a dog on that piece of work, and we'll get this between centers. So I'm going to start by turning this whole end down here. We got this large diameter, which is 0.875, 7/8 inch. So I'm going to start by just turning down roughly to the dog here, just shy of the dog, which will clear that area there, and get that turned down to the largest diameter, which again is 0.875. I'm going to start with just making a fairly light pass down through here. So I thought I had this worked out. I am getting some chatter in here. I'm just making a real light cut, and I'm getting some chatter in here. When I had a piece just chucked up into the chuck, it wasn't giving me any problems. I think this live center that I've got in here is just bad, which it shouldn't be. It's a brand new live center. But I think this live center's got some issues. I'm going to have to order another live center. And in the meantime, as much as I hate to do it, I need to get this job knocked out. So I think we're going to just go over to the other Monarch bigger lathe and just do it over there, because this is not giving me an acceptable finish that I need for this machine. And in the meantime, I'm going to order me another live center and see if I can resolve that issue. All right, well, here we are back over on the good old trustworthy Monarch Model K. I'm going to speed this up a little bit. We are turning between centers. I'm going to come in here and touch off on this. I'm just going to give it a little bit of a feed. I want to get a good diameter on that. We just turn that down. Get a rough diameter here. We're at 1.101. We're taking that down to 875. Take another pass down through there. So just FYI, I did order a new live center for my 10EE. I also ordered a few other little tools. I got to looking, and I just that lathe takes a much smaller tool than this lathe does, just because of the size of the tool holder. So I ordered some other tools to go along with it as well. All right, that's pretty close. I didn't actually have a threading tool that fits that lathe to do my threading. I'd have probably had to come over here anyway, but got dialed in. But hopefully we'll have that. We can play around with that 10EE down the road. Another kind of downside to it compared to this lathe is I do have the digital readout on this lathe. I have not installed a digital readout over there on the 10EE yet. That's on my to-do bucket. I just need to spend the money to do it, and I just haven't done that yet. All right, we're at about 922. 922 is where we're at. All right, I purposely went just a little bit on the large side. We're going to fuzz back across this, and we should be pretty much right where we want to be at. just moved in about an hour and a half. Check this one. All right, right where I want to be. Just so you kind of follow where we're along here. This is the part that we're making, and the diameter we just turned is this large diameter right here. So we went just past it a little bit. We'll clean the other side up on the other side of it. So now I need to cut the next largest diameter, which was this one right here, which according to my measurements, I'm just going to double check this. What's this? 50, 60, looks like we're about 69. All right, so I'm just checking this with my micrometer, and we're at 0.669 and about 4/10,000ths. And looking on my decimal equivalent chart, that does not come out to anything on a fractional inch size. So I looked over on my conversion chart for metric to inches, and 0.6693 is 17 millimeters. So we're like a 1/10,000th over 17 millimeter. I'm sure that's what we need to do. So we're going to come in and do that. So this part appears to be a mixture of fractional and metric. Yeah, fun stuff. No big deal. You know, we're measuring. It doesn't really matter what units you're measuring in, as long as you're measuring to a close enough number. You know, as far as the increments go, it's going to be the same. So I'm going to do this in inches because that's what I'm set up to do, but that is the 17 millimeter diameter we're going to cut. But we're going to cut it to 0.6693. That's what we're shooting for. All right, now, next thing I need to do is figure out how far in I need to cut from the end to get to that shoulder. So what I'm talking about here is this shoulder right here. How far in do I need to come to that shoulder, because we need to turn it down all the way to there. So let me go measure that, get that figured out, and we'll get over here and get it done. All right, that should be just right back there we want to be at, and let me go to my 3.2 shoulder done as well. I'm going to recess back down that bottom. Just going to put a little bit of a indentation there with my tool, because that's the way the original is. Okay, that's more like it. I'm probably going to have to again polish that out to that last little bit there. Let me see where I ended up at. Yeah, so I'm reading about 5/10,000ths there when I need to be. I'm about 2/10,000ths over. No big deal. All right, next diameter. Just going to go down here and touch off again, and we are on 0, so I'm going to go in. This needs to come in 2.655. It should be about right there. And again, this diameter is 0.625. Be about 0.650 on the diameter. Yep. And we're going to 625. I'll tell you what, we'll go just a thou or two over and come back and clean it up on a light pass. Yeah, I'm 3/1000ths over, and that's what my digital readout's reading as well. Less fuzz in here. All right. Again, I'm a couple of 10/1000ths large, but we'll polish that down at the end. Let's go ahead and cut our shoulder in there, which is at 2.655. Right here. And again, it actually goes down below the surface on the original. So I'm copying that feature right here. I still got to cut that groove in there, but there we go. All right, so next, this shoulder should be a 1/2 inch, and I need to figure out how deep it needs to go. All right, our next shoulder is going to go right here, 2.025, and this goes down to 1/2 inch diameter. About 10/1000ths to take out of there. And last step, the end down here where the spline gets cut should be 450/1000ths in diameter. And that is, it comes in 0.925 from the end. Put a mark on there. Perfect. All right, and cut that shoulder. There we go. All right, I need to go in here now and just check all my measurements and do a little polishing to get them to the final sizes. That's right where it needs to be. This one, I think, was fine. Yep. And this one was fine. All right. So that groove is 42/1000ths wide. I basically just found a piece of high-speed steel. I found a parting tool over in my drawer that was close to that, and I ground it down to 42/1000ths wide. It needs to be in 90/1000ths. The leading edge needs to be in 90/1000ths from the shoulder there. I've got it there, and it needs to go 50/1000ths smaller diameter than out here. So 25/1000ths deep, 50/1000ths total. So we're set up where we need to be. We got the right cutter in there. I'm going to feed in. I'm going to zero out my DRO whenever we touch off, and we will go in till we read 50/1000ths, which will be a 25/1000ths groove, 50/1000ths total diameter difference. All right. Feed in till we just touch off right there. And I'm just going to go in 50 thousandths. 20, 30, 40, and 50 right there. That is it. All right, this side is done. I'm gonna pull this side out, and I'm gonna get a dog that I can put on this end, and we're gonna flip it around, and we'll cut the other end. This is the beauty of turning between centers. I can flip that thing around. They'll be running perfectly concentric to the side I just cut. So let me get a different dog, and we'll be ready to move on. And I got a different dog in here. It's just turning loose right now. I've set it here in just a second. Flip that around. All right, now we need to work on this end. So you can kind of see there what we're going after on this end. So we'll turn this end down to, what is that? 3/4 of an inch, 0.750. And we'll create a shoulder back here. All right, here we go. Touch off here. This gets turned down to 3/4. 0.750. Just get a measurement on that. Make sure my digital readout's reading like it should. 1.131. Get these rings out of here. I also want to just touch off back here, mark my 0. I'm going to mark my depth here. Right on the money. Okay, now let's get that shoulder in there. So 1.445. Perfect, 200 thousandths wide. And our last diameter here will be down here on the bottom, and that gets turned to 1/2 inch, and that comes in 0.535. And we're going to, what I say, 0.535 on the depth. Right there. This end gets threaded. I'm going to put a pretty good little recess kind of back down to that bottom. About like such. And that gets threaded to 1/2 inch, 20 threads per inch. We'll go ahead and break some corners. Barely break that one. This one gets a nice little chamfer on it. And let me get set up for threading. That last little bit. All right, here we go. Single point threading. I'm going to start by chamfering that front edge to that thread pitch angle. Come in here on my compound, just barely make a cut. I'll make a scratch pass here and we will check our thread pitch. Supposed to be 20 threads per inch, and looks just right. Put a little cutting oil on there. Go back to 0. Do about a 10,000ths feed. You know what? I'm going to slow down a little bit more. That's a little bit faster than what I want to be going. Another 10,000ths feed. Do about a 5,000ths feed. Clear those chips off. And I don't have a 1/2 inch 20 nut to thread up on there, but what I do have is a 1/2 inch 20 die. So what I think I'm going to do is I'm just going to take this out of the lathe and we will finish cutting that using a die. It's already started. It'll be real easy just to finish it up and it'll be the size. Because it's between centers, I'll just take it off and do that, but we're through with our turning. Over at my workbench, and what I'm going to do is I'm going to put in my copper jaws here on my vise. This will help protect this shaft from getting marled up when I put it in the vise, but still let me grip it. And we'll take our die stock and we'll just run right down this, and that should open that right up to the right thread pitch, and it shouldn't take a lot to get it started. Shouldn't. Goes. And we'll just turn that in there. I like starting my threads on the lathe. If I'm going to use a die like this, you can finish it up with the die to get it to the right size, but it just, by starting it on the lathe, you're taking most of the metal out of there, and now you're just kind of chasing those threads. All right, now I'm going to flip this around and run it on there backwards just so that the threads will go all the way up to that shoulder, because those threads are tapered, and we want them cutting all the way down to the bottom uniformly. So I just run it up on there backwards until we get to the bottom right there. And that thread should be right on size. And our turning work is done. So we've got this completely all to size. The only thing that's left to do now is I got some milling machine work to do. There's 2 more operations need to be done. We need to cut the splines down here on the end, and then there's obviously that woodruff key that gets cut up in there. So, but other than that, this thing is done. We got the lathe work done. And I think we'll do setting up the dividing head and cutting the splines and cutting that woodruff key. That'll probably be a separate video. Well guys, there you go. One shaft knocked out on the lathe anyway. Splines, that's something, I think I may have cut splines in one other video a long time ago. I don't remember. It seems like I remember cutting some splines. but we'll get set up to doing that. Very similar to cutting gear teeth. I do fortunately have the piece that fits up on here, so that's going to make this spline cutting job a lot easier. We'll probably just have to take a little bit until we get it to fit, because I don't have any specs on this as far as how deep those need to be. I might be able to look it up in Machinery's Handbook if it's a standard size, but I'm not even sure what size this is, so we'll figure all that out. But get set up for cutting splines, and then Woodruff key, yeah, that's no big deal. You've seen me do that before. But that'll be coming up soon, and hopefully get this shaft knocked out so we can get this back over to Stephen and he can get his project moving along. Guys, for that, that's going to be a wrap. As always, thanks for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Please hit that bell icon up there to get notifications when new videos are posted. Leave a like, leave a comment. Again, really do appreciate those. It helps out a lot. Big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships, all which are great ways to help support my channel or any other YouTube channel that you feel like you're getting value out of. If you feel like you're getting some value out of it and you have the means to be able to contribute something, even if it's just $1 a month, it really does add up and it really does make a difference. And I really do appreciate the folks out there that do that. And if you can, please consider it. And with that, we're going to sign off. We'll catch you on the next video. Again, as always, thanks for watching.